How much, I think we'll have time to do questions from your previous assignment. What am I trying to do? I'm trying to give you notes.
We didn't have to do the restrictions on our homework, right? You said no to that?
I don't remember.
I thought you did.
I guess I said that. Okay. We are going to combine rationals. All right, so rationals are fractions. So let's say I have 3/5 plus 1/2. We have 3/5 plus 1/2. In order to do that, I need a common denominator. What is my common denominator?
10.
Huh?
10.
Yep. It's 10. So notice how I write this. So what do I need to multiply this denominator by?
2.
2. Which means I also need to multiply my numerator by 2. So it would be 3 times 2 on top. Plus, what do I need to multiply this second fraction by?
5.
Times 5, which means I need to multiply also the numerator by 5. So 1 times 5. Let's get settled over there. All right, so we have 6 plus 5 over 10, which is 11 over 10, and we're fine with that. Let's do one more with the numbers, and then we'll get to with the algebraic expression. So let's say I have 4 over, let's not do 4. Let's do 5 over 6 plus 3 over 4. Like that. All right? The first thing I need to do is get the common denominator. What's my common denominator?
4.
Okay, 24 would work, but that's not my least common denominator. How do I know what my least common denominator is? One way is to look at the factors of 6 and see that the factors of 6 are 2 and 3. If I prime factorize, and if I prime factorize the 4, the factors of 4 are 2 and 2. And I see that the least common multiple, see the least common denominator is least common multiple. And when you do least common multiple, you take all the combinations that have like this would be 2, this 4 has 2 2s, so I need those. And this 6 has a 3. Okay, so my least common denominator would be those all multiplied, so I get a 12. That's the least common denominator. 24 works, but then I have to reduce in the end. What do I need to multiply my 5 by? How do I go from 6 to a 12 through multiplication?
2.
So I need to multiply top and bottom of this fraction by 2 plus, what do I need to multiply this fraction by? 3, because I need to go from 4 to the 12 by multiplying by 3. So now I have 10 plus 9 over 12, which is 19 over 12. Any questions on how to just add fractions? That's all we're doing, really, is adding fractions. Okay, I'll take that as a no questions. All right, so let's say I have something a little bit more complicated. Something like this, perhaps. I do it the same way. I need a common denominator. Now I see how many x's do I have on the left, on this leftmost fraction? 2. Okay, so, and I only have 1 x over here, so I'm going to need 2 of them. Need the most. And then this fraction here, its denominator does not have a 3, but this one does, so our common denominator is 3x squared. Thus making this a little bit tricky, I do need to think, what do I need to multiply this first fraction by? Well, a 3. What do I need to multiply this second fraction by?
X.
X. Now we'll simplify. We have 15y plus 2xy squared all over 3x squared. If possible, I would combine those, but it is not possible, so I will not. Okay, what's my common denominator for this one?
21.
Yep. Okay, so I need to take the one that has the most. The most of each thing. Okay, so I have 3, I have 7, okay, I have the x cubed, so this x is already counted. I don't need x to the 4th, and then the y squared, so the most there. So what do I need to multiply the 5 by?
7 x to the second y.
Nope,
Just x squared.
just 7x squared. Okay, this one already has the y squared, right? I look at this denominator and I ask, how do I get this denominator to become that denominator? So it would be times 7, and then I need an x squared to give me x times x squared is x cubed, and then I already have the y squared, so I don't need to worry about that. Then minus 6, what do I need to multiply the 6 by? 3y. So then I get 35x squared minus 18y all over 21 x cubed y squared. And if I could, I would combine things in my numerator. Now at this point, these are actually the easiest that they'll be. Those two examples right there. Most of them are much more difficult. So let's try one of the big kahunas. Okay, so our first thing is going to be to factor. Okay, we do need to factor. Specifically though, our denominator, we aren't so worried about factoring our numerator, mostly our denominator. Alright, so let's factor our denominators. We get x minus 2, x plus 2. We have an x plus 2 here. So what's my least common denominator?
Both of them?
X minus 2 and x plus 2. Do I need another x plus 2? No. Just one of them is fine. What do I need to multiply my first fraction by? Well, the 3x is fine. I already have that denominator. Then minus, what do I need to multiply the next fraction by?
X minus 2.
And now we'll distribute this x. We'll leave our denominator factored. We'll collect like terms. So we have negative x squared plus x Now, there is an additional step. Now on this one, it doesn't end up mattering. But I do need to factor my numerator to see if it cancels with the denominator at the end. So in this case, I could factor out an x, and that would give me negative x plus 1. Then I have x minus 2, and then x plus 2. Right there. And I see nothing cancels, so it ends up not mattering. All right. Let's go on then to another one. Let's see here.
Then once we factor the numerator and it doesn't cancel, we can just go back
To the other one,
answer?
yes.
Okay.
Yeah. There's no need to go any further on that. Let's see here. Get a good example. Here's a good example. So we factor our denominator. We get x minus 2 and x minus 1. And of course, this fraction, there is no factoring. It's already done. So what's my common denominator?
X minus 2, x minus 1.
What do I need to multiply the first fraction by?
X minus 2.
In the second fraction? Nothing. So it's fine the way it is. Now what do I do?
Distribute.
Okay, then I'll combine like terms. So I get x squared minus 1 over x minus 2, x minus 1. And in this one, it will matter. So I can factor. I'm going to have to factor that. If possible, I do it to check to see if something cancels in the denominator. This time it does, because when I factor that, I get x plus 1, x minus 1. And at bottom, I have x minus 2, x minus 1. And we see that the x minus 1s will cancel, giving me the final answer of x plus 1 and x minus 2. Okay, let's do the big kahuna. Any questions on that? Actually, I do want to do one with subtraction, because subtractions can sometimes cause us bad things to happen because we don't deal with our negatives correctly. So,
We didn't get the last bit on that, so.
okay, I'll go back for a second. All right, I'm going to go on. All right, walk me through it. What should we do? Factor. How do I factor this one?
You take out minus 1.
Yep. And the other one?
Take out a 2.
Okay, so what's my least common denominator? Nope. Not just x minus 2. 2x and x minus 2. See, I have an x here, an x minus 2, so I got that one. And I need a 2. So what do I need to multiply the first fraction by? By 2. And how about the second fraction? By what? By x. Now I need to be very careful with this negative and with the parentheses. I want to make sure I take care of it.
Isn't that a minus 2? On the 2 parentheses x minus 2?
Where?
Like on the fraction.
Where are you talking about? My denominator is x minus 2 and x and 2. So is our
So
denominator good?
Isn't it x minus 2? Right here.
Right here?
No.
Why? Here's my numerator. X plus 2. There's a plus sign there that I see.
Yeah, I was just looking at the denominator.
The denominator, because it's very similar, we're multiplying this by 2. All right, now we need to be careful with this negative. So I'm going to, when I distribute, I take the negative with it. So it's negative x squared minus 2x. See, this negative goes with this x when I distribute it. And then I have 2x plus 4 all over 2x squared minus 2x. So then I'm going to combine like terms. Now, actually, I would not, I should back that up. I would not actually multiply out my numerator, or denominator, I mean. Okay, I'm going to combine like terms in my numerator. Now, here's a trick. Here's a trick. I need to factor out a negative. Do you see what I did there? Generally, when we factor, we want the highest power of x to be positive. So I factored out a negative. That means I'm going to be able to factor out that numerator easier with a minus 2 and a plus 2. Now we see something cancels. The x minus 2's leaving me with negative. Then I distribute that back, negative x minus 2 over 2x for our final answer. So there's a lot of little steps here, but in general, you're factoring to get your common denominator. Once you get it, you're going to multiply the appropriate numerators, combine your like terms, then factor again to see if anything cancels to reduce your fraction. Does anyone need to see another one with subtraction? Okay, I'll take that as a no.
Wait, 1 second.
Oh.
Can we do it the quick way and I calculate and do it the long way right there? Like, you know how you put 1 in for A and then the augment in for B and then find the inverse? Is that what you want us to do right there?
Augment with 1, 0.
Yeah, but you want us to put, now calculate A and then B, 1, 0, 0, 1, and then put in, and then put that.
Yeah, but write your steps right.
I thought you did that.
They would be the same thing. And it sounds like you're almost mixing up solving with inverses and finding inverses. Those are two different things.
And you don't want to do this. You said 1 through 8.
Yes.
Okay.
All right.
Oh, Caroline, I thought you got the cool table. I got the cool table.
Okay, okay.
Just kidding, I don't understand what you're doing.
Okay, we'll go over another example. I need to make sure I get the sergeant one. Let's focus on what we're supposed to be doing. Okay, so in this case, I have a big old division. And I could think of it as 4 over x plus x over y divided by this thing. I could think of it like that. But it actually ends up that doing it this way is longer and harder. So I'm going to do, it's going to look really, really sloppy. But what I'm going to do is try to clear out these fractions a step at a time. So I see that the common denominator right here is what? Yx. So I'm going to multiply the numerator and denominator by yx in an attempt to clear that out. So this is actually just a 1, which is why it's fine. So I distribute this to both terms. So in the numerator, watch what I do so you can see what's happening. In the first fraction, x will cancel with that x. Do you see what I'm saying? So I get 4y. Okay? And in the next fraction, y cancels with y plus x squared. Okay, now I'll do the same thing in the denominator. The y's will cancel, so I get 3x. And the x's cancel plus 2y. Then I factor and simplify if possible. It is not possible, so now I'm done. That's the answer. No matter how complicated they are, however, when I have fractions with pluses and minuses, generally I want to do a process like this. Okay? I'll do one more, and then we'll back up and just do a one where we just are adding and subtracting. But the process is the same. We are getting a common denominator and whatnot. So this is going to be lots of fractions within fractions. Now there is another way to do this. I could add those fractions at top, and I could add the fractions at bottom, but it turns out that's a way longer way to do it. This is a plus. Okay. So I look at both of these this big whole numerator, this whole denominator, and I ask myself, what is the common numerator or denominator between all of these things right here? And I see an x minus 1, and an x plus 1. And I'll multiply this denominator by that same thing. So I considered all of these denominators. Do you see what I'm saying? Every single one of them. Now when I multiply my numerator here, what cancels on the first fraction? Just the x. Okay? I don't know if I want it to go that far. I think I don't want the x. Let's see here. The x canceled, and that x doesn't. Well, let's just see what happens. Okay, so the x minus 2's are going to stay. And then the x cancels, we have x minus 1 and x plus 1.
If you do all the x's, then you'll only have like 1's at the bottom, right?
That's what I'm, well, let's hold on. Okay, so then the x plus 1's cancel here. Do you see what I'm saying? So then we have an x and an x minus 1. And then at the bottom, yeah, I really think I don't want that extra x, but let's just see. Alright, so at the bottom we have 3, and then an x, and then an x plus 1. Because the x minus 1's canceled. Minus the x plus 1's cancel. So we have x and x minus 1. Now, of course, I'm going to have to multiply all this out. Do you see what I'm saying?
Can't you just cancel it that step?
Ooh, careful, careful, careful. Can I do this? The answer is no. I can only cancel through what operation? Multiplication. There's a bunch of addition and subtraction here, so I cannot do that. So, I mean, if there were an x minus 1 on this one as well, then I could do what you're suggesting, but it's because I factor that whole thing out. So at the top here, I'm just going to do a process of multiplying here. So I have an x minus 2. I'll do this x minus 1, this is x plus 1. I'll get x squared minus 1 at the end. And over here, I always do the things with the variables first. So that's where I'm getting all that. I'll multiply down here. I'll distribute that negative x. Squared plus 3x minus x squared plus x. So this is going to extend on to the next page, so I'll have to copy this. I'm going to multiply that out. I'll multiply this out. I will get an x cubed in my mix. So x cubed minus x minus 2x squared plus 2. I just multiplied that all out. Okay. I'll combine like terms, but I'm going to try to copy this onto the next page. So copy, paste, please let me review. That's letting me rotate you. I don't want to rotate you. I'll do this. Boom, it's really too big. Okay, alright, so that's what we got from the previous page. We'll combine our like terms. I see an x cubed, nothing like that, but I do have an x. Looks like it looks like these all are going to cancel each other out. And then, let's see, at the bottom I have 3x squared. Nope. 2x squared plus 4x. That's looking really nasty. I don't even know what problem this is. Alright, what did we start with? There is another way to do it, so if someone would like to see the other way as opposed to the way I'm doing it right now, just let me know and we'll go over that. Okay, I'm going to factor that denominator right there, just to see if anything's going to cancel out. Okay, this does factor, but to do it, we have to do it. We did synthetic division this year, didn't we? Mm-hmm. Yeah, we did. Okay, so 1, -2, 0, and 2. And if something cancels right, what would I divide by? It would be -2, right? So if it's factorable, it's going to be a -2 if anything's going to help me out. So 1, -2, -4, positive 8, -16. So the -2 does not work. Maybe well, an x doesn't come out. So I think we have it. It doesn't agree with what the book has, but I don't know. I'm okay with that. Just the process that matters. Let's try one that's easier. All right, here's an easier one. Do you see what you... Okay, so on the right-hand side here, I'd multiply this top by xy. and this bottom by xy. That clears out that denominator. The common denominator is xy. So at the top I get x squared y, and at the bottom, see if I distribute this, the x's will cancel on the first fraction, so that leaves a y. And then over here, the y's will cancel, leaving me with x. So I have x squared y over x plus y.
What did the book say for that other one that we just did?
It says it's x minus 1 squared over 2x.
Well, this is what
So
about-
apparently we made a mistake along the way. This x plus 2 should cancel with something up here. So somewhere along the lines with multiplying and simplifying, I lost something. Maybe it was right here when I did that. Plus 2. I mean, I don't see it, but whatever.
If you just did x, would that change, and you cancel the x's, would that turn into a 1? So would that x plus 1 be 1 plus 1? Or would it just be 1?
Up here?
Like if you just had x as the denominator, and you're multiplying it by everything. So that x plus 1, would it become 1 plus 1, or can you not do that?
I'll have to look at it later. Alright, we are almost out of time, and I wanted to make sure that I hit once more the most common type of problem that you'll need to be doing, which is just straight up adding and subtracting these. So let's say we have 3x over x squared plus 2x plus 3. We'll subtract from that 5 over, let's say, x squared minus 1. So what do I need to do? Factor. So I factor my numerator or denominator here. I want this, sorry. That fraction's wrong. I'm changing this. I mixed up my 3 and my 2. This should be a 3, and this should be a 2. Did I do minus? Minus is fine. Minus 5 over x squared minus 1. There, that's better. Alright, so we factor this. And we factor this one. And we use that to determine what our common denominator is. So as I look at both of these denominators, I see that this denominator has an x plus 2. This one doesn't, but it doesn't matter that this one doesn't as long as I have one of them. So there's an x plus 2 in my denominator. This one has an x plus 1. This one also has an x plus 1, so I just need one of those. And then this second fraction has the x minus 1, so an x minus 1. It doesn't matter that this one doesn't have it. I need a representative from all of them. Alright, so what do I need to multiply the first fraction by?
X minus 1.
And what do I need to multiply the second fraction by?
X plus 2.
Yes. Now I want to be very careful with that negative 5. So now I distribute, and I get 3x squared minus 3x minus 5x minus 10. I'll combine my like terms and I get 3x squared minus 8x minus 10. All over x plus 2, x plus 1, x minus 1.